The last thing we're going to do in this lesson is talk about finding a data value corresponding to the kth percentile. Once we find the data value, we're going to write a sentence that explains what that data value represents. In these problems, we're going to be given the area. So notice here, we're not trying to find a probability. We're not trying to find the area under the curve. We're trying to find an x value. Let's go ahead and consider the problem below. In exercise number 5, we're being told that a farmer who grows mandarin oranges finds that the diameter of these oranges that he's harvesting follow a normal distribution. The mean diameter is 5.85 centimeters and the standard deviation is 0.24 centimeters. Here we're looking at the distribution composed of the diameters of mandarin oranges. We're going to call this distribution X. We know this distribution follows a normal distribution. We have the mean and we have the standard deviation. Let's go ahead and write X follows a normal distribution with mean equal to 5.85 and a standard deviation equal to 0.24. Now, let's go ahead and consider part A. This is going to help us so that we don't have to be reading the problem as we're trying to solve the problems below. Okay? We can look at this notation. We know we're talking about a normal distribution. We know the mean and we know the standard deviation. In part A, you're being asked to find the 98th percentile for the diameters of mandarin oranges. Then, you're going to write a sentence to interpret the percentile. They are asking us to find the X value, the diameter of the orange, that marks the 90th percentile. Let me help you visualize this. Here we have a normal distribution. Here we're trying to find the X value such that we have 90% of the area below this X value. Remember, if I tell you that X represents the 90th percentile, you know that 90% of the data values are below this X value. That is what I'm saying here. If we have 90% of the data values below this X value, then we have 0.90. Remember, the area under the whole curve is 1. The area below this X value here is 0.90. Or you can just write 0.9. Notice in this problem, they're giving us the area under the curve. They're asking us to find the X value corresponding to that area. We're no longer going to use the normal CDF function. We now have to use a new function. If you're using a calculator, you're going to use the function IMB norm. This function is going to ask you for the area to the left of the X value you're trying to find. It's going to ask you for the mean and it's going to ask you for the standard deviation. Okay? When we use the normal CDF function, we're trying to find the area under the curve. This time is the other way around. We have the area under the curve and we're wanting to find the X value. Here, the area to the left of the X value we're trying to find is 0.90. The mean is 5.85 and the standard deviation is 0.24. Let me show you how to enter this on your calculator. We're going to click second bars to go to the distributions. Notice we have a list of the distributions. We're going to go down until we see IMB norm. In my screen, IMB norm is the third option. Now I'm going to click enter. Here I'm going to type in the area. Then I'm going to type in the value of the mean. The mean here is 5.85. The standard deviation is 0.24. Now, my calculator is a little bit more advanced. It lets me indicate whether I'm giving the area to the left, to the right, or at the center. Other calculators are not going to be this advanced. Okay? So when you type in your area, you need to type in the area to the left. Here I'm just going to click on left because I have the area to the left of the X value I'm trying to find. Let's go down and let's press enter. And then we need to press enter again. This is the X value we're trying to find. I'm going to go ahead and round to 2 decimal places. 6.16 is the diameter of the orange that marks the 90th percentile. That means that 90% of the oranges have a diameter less than 6.16. Again, going back to our notes, we approximate the X value to be 6.16. We know that the area below this X value is 0.9. Again, we know that 90% of the data values are below 6.16. Now, I also want to show you how to do this on Google Sheets. On Google Sheets and Excel, you're going to use the following function. Econorm, INB, you're going to open a parenthesis, and you're going to need to enter the area to the left of the X value you're trying to find. Then you need to enter the mean, and finally you need to enter the standard deviation. Again, here the area to the left is 0.9 or 0.90. The mean is 5.85 and the standard deviation is 0.24. If you enter this expression into an empty cell on Google Sheets or Excel, you should be getting the same answer. Okay. Once you round to 2 decimal places, you should be getting 6.16. Now here, I want to make sure that we understand what this X value represents. So let's go ahead and write a sentence that interprets our answer. We're going to say that 90% of the mandarin oranges have a diameter that is less than 6.16 centimeters. Again, X equal to 6.16 marks the 90th percentile. Now, after doing part A together, I am confident that you can do B on your own. Below this video, I'm going to be including a question where you need to provide the X value that corresponds to the 75th percentile. Then I'm going to have a multiple choice question where you're going to be asked to interpret your answer. Okay. Now, I do want to do part C together. This question is going to be a bit more challenging. In part C, we need to complete the following sentence. The middle percent of mandarin oranges from this farm have diameters between blank and blank. Here, we're looking for two X values. Let's go ahead and visualize this. We are looking for two X values. We're looking for the two X values that capture the middle 20%. These two X values are going to capture 20% of the data values. That is the same as 0.2 of the area under the curve. The X value here on the left, I'm going to go ahead and call this X1. The X value here on the right, I'm going to call this X value X2. That way we don't get confused, right? Because they're not the same, so they should not be called the same. I should not be calling both of them X. Now, here's my first question. What is the area below X1? What is this area here? Let's go ahead and think about it. We have 20% here in the middle. If we go ahead and take 100% minus 20%, we get 80%. This percent corresponds to the area here on the right tail, and it corresponds to the area here on the left tail. So let me go ahead and highlight the area here on the right tail. That is the area above X2. Now, if I want the area below X1, then I need to take 80% and I need to divide it by 2. 80 divided by 2 is 40. Okay. That means that we have 40% of the data values below X1. That is 0.40 of the area below the curve. Here above X2, we have the other 0.40. Okay. Notice 0.4 plus 0.2 plus 0.4 is equal to 1, which is the area under the whole curve. So let me go ahead and erase here. You have a function on your calculator in Google Sheets and Excel that can help you find an X value if you provide the area below that X value. Let me make a note here. The area below X1, let me make a note here. The area to the left of X1 is 0.4. Let me make a second note here. The area to the left of X2, the area below X2 is equal to 0.2 plus 0.4, right? That is the area below X2. The area below X2 is equal to 0.6. Now I'm going to stop here. With the two remarks I just made, you should be able to find X1 and X2. Below this video, I'm going to ask you to provide those X values. Here, we're saying that between X1 and X2, we have 20% of the data values. This is the last problem you're doing on this lesson. Again, I encourage you to reflect on what we did in this lesson. In this lesson, you learn how to use technology to find probabilities under a normal distribution, and you learn how to find the X value corresponding to a given percentile. Those were the learning objectives of our lesson. I encourage you to go look for examples to help you practice those learning objectives.